keep only hands-on session kind of. So if you people have your laptops or any system open, so it will be better so that you can do with me side by side. So firstly, I would like to ask that how many of you have already installed our software in your systems? Do you have already installed, or it is a free software actually? There's nothing like that is where you need to pay anything. This is free only. So if you people are using your laptops or anything, and if you have a good software, good internet connection, then you can download now itself. But means if you don't have, means it is I think something like 200 MBs or something. So it will take little time to get downloaded. But let me see if what is the size of the software. If you can download and start doing side by side, I'll start doing. So you can keep a follow, and I will say git git. Okay. So here I am showing you that how you can proceed to download. See, there are two softwares you need to download. One is R Studio, okay, which is soon it will be called as Posit maybe. So if uh, you search R Studio on Google, this will be what you will be getting. You can click on the first link directly, and this will take you to the website of the R Studio itself. Okay. Once you are on the website of the R Studio, you can here there are two options. Okay. First is install R, and then install R Studio. So both you need to do one by one. Okay. First you need to download R. Okay. This is near about 100 MBs, and this one is near about, it's already written here, this is 216 MB. So first you need to install this. Okay. Before installing this, one number you need to install R. First thing you need to install R. Okay, download and install. Okay, so I won't download because I have already downloaded it. So if you click download R, okay, then this window will show up. If you click the link download R, then this window will show up. In this window, see, let me zoom in a little bit. So there are few options: download for Linux, download for Mac, download for Windows. So as per your system, if you are using Windows, click Windows. If you are using Mac, then click Mac. Apple laptop, if you are using, then you have to click Mac. Linux, I think very rarely anybody is using, but if you are using Linux, then you can go for the Ubuntu if somebody is. So I am using Windows, so let me click download for Windows. Once you reach here, then you just need to click this install R for the first time. Okay. Install R for the first time. Once you click this, the downloading will start. Once you click this link, sorry, once you click this link, then open to this one, no? R. So this is the R 3.4.3.3. This is the latest version. So you click this one means you get the latest version of the software R software. Once you have downloaded and installed this R software, second step only you have to go here. Then again you will come back to this place. So once you have finished with R installation of R, then you will come here, click this. So if once you click this, directly it will start download. Download, because this is directly for Windows, no? If somebody is using some other, then here it is, okay? On the lower side, for Mac it is here, okay? For Ubuntu it is here. Okay? So you can download, respect. Hmm? So if you can keep downloading side by side, and by then I will just do the basics, and once you have installed means you can do side by side as you wish. But I will be happy if you do with me, because that way only you learn more. Okay. So let me share the screen of the R Studio. So you need not to open R, okay? You instead you are opening R Studio. Once you have installed R Studio, we'll share. We will do our work mostly in R Studio. Okay. This is how R Studio. Once you have installed, this is how it will look like. So I think let me increase the font size and all, so that for you visibility will be better. Okay. I think now it is better visible than before. I think this is the that much only we can increase. Okay, no problem. So let's first understand what is this four small windows you are seeing. why these are four windows, what is the meaning of each window. First thing that only we will understand. Okay. So when you see these four windows, here you see this is by default setup. Okay. This is the default setup. So when you will open it, it will open like this only with a blank four windows. Okay. This is the basic layout. This is I have written. These all things I have written. So that's why it is showing. Otherwise, it won't. It will show as a empty environment. So this is what we call script environment. This one. Okay. This one is script. Here we are writing the script. Okay. Whatever we write here, we can write for just comment purpose, and we can write the code also. Both things we can write. See this area. Okay. This area is called environment. Now, what is the environment? Environment is it will show you what data you are using, what are the variable you are defining. We will know more once we start using. I'll show you how environment is help. Then in this window itself, there are 3-4 tabs. One is called history. History showing all the previous work that I have done in this. Okay. This could store up to so much of your previous. Okay. The last session when you did. And then there is connection. If you are connected to someone through your LAN or maybe WLAN. Okay. And then this is your tutorial. There is a package LearnR. So you can also use this LearnR package. Okay. Once you install this, there is a uh, stepwise it will guide you how you can start learning. Okay. So I think I have already installed this LearnR. Um, okay, I installed in the last version. After update, I have. Okay, no problem. So this is a very nice package, LearnR. Anyone can learn to buy. There is very like stepwise they have shown. They will let you. They will make you write the code, and then from that code you will be evaluated as well as what happened. Oh, actually, sorry guys, there is some connection issue. Okay, I think we are ready. Okay. So this is your code environment. This is your script environment, script window. This is your environment window. Now what is this? This is console. This third window is called console. Okay, already, although there are two more tabs, terminal and background jobs. We are not much concerned about this terminal and background jobs. Terminal also you need not to have a need not to worry about much. But this console only mainly we are concerned. Okay. So And this last pane, this one, this is for plots. If anything we plot, it will come here. Also, it is used for packages. All the packages that are installed are listed here, that are being installed by you or already that exist in the pre-installed. Some of them will come pre-installed, some of them you will install, some of them while installing one package they will be installed automatically. There are a few packages like that also. Then this is that packages that is also coming in this small tab. Then there is help environment. Help is also coming here. If anything, I will tell you how to get this help for any function, anything. I will tell how will you reach here, help environment. Then there is presentation and previewer. This is not much of concern for today, but like these are little advanced features are. Okay. Then files. This file means what is in what place you are working. That file setup it will. Okay, you want to import some file, export some, like that. Hmm. So let's begin with the basic coding. Okay, but how I want to tell you how it works. So first, let's get straight into the console, and then I will tell you how to use the script. Okay. So there is minimize, maximize buttons are there on this corner. So I am maximizing the console. Okay. So while I did this, just to use more screen space. Okay. Okay. So firstly, I will show like how basically it works. Like it is very basically, you can see it is like if we give the basic command like this, pro plus 3. I think still font is little small. It is little small. Can we increase it further or it is visible? Tell me guys, if it is okay, it is visible or we should increase it further.
It is visible, sir.
Visible? Okay. Okay. So it is a calculator only, but it is little advanced level of calculation. Like how, see, it is we can do basic calculations like this 2 star 5. Okay, 5 divide 5. Okay, so this is all these things. Simply it will work with the little complex things also, just like 3 plus 3 plus 5 into 7 minus 6 minus 3 4 divided by 5 plus 21 1.3. So anything complex, simply you use the board mass also. Simply this is compatible, no issues. Okay, but don't use these curly brackets and all. Okay, these and all have a separate function. These are used for some other issues. Mostly what we will use is the round bracket. Don't use curly bracket and square bracket. We use it, but these are used for different purposes in this software. Now, sir, what is the use of showing this plus minus? We can do in a calculator also plus minus. So you need to be acquainted like how this software works. That's what I need you to know. Okay. Now let's do something. These are all basic uh, characters. Okay. Also, it is this is your mathematics numeric. This also deals with characters. Like if you write simply, you write A, it does not identify what is A. But you write A in inverted commas. That is we call quotes. We call quotes. Then it will give you the. This is a very common uh, thing that in computer science classes anybody will start means they will first thing they will tell you to do print hello world. See print hello world. Okay, this is the print hello world of the R software. Okay, now there are some uh, so till now we understand that R understand characters also, R understand numericals. Both things it understands. Okay. So this much you understand means we will proceed with the uh, script thing. Now listen. Here in console, if I write a command, if I write 3 minus 5, I press enter and it give me the result that is minus 2. But in case I want to write the code 2 plus 5, but I do not want this to run. I do not want to run. I want to run later. I want that it should not run now. It should run later. I press enter. I just keep it here. Only when I want it to run, I come to this row number 2, or I select this much. No need to select always. Just you need to come to this row, starting of the row or the end of the row, or even middle of the row. If you come, and then there is a button here. Here it is. Okay, in this place. The button name is run. Button name is run. If you press run, then it will show in the console. Here it is showing. So that means your code 2 plus 5 has been sent to console. There it is executed in the console and output is given. So simply you can think in script you can store your code. You can store your code and you can use it again and again. Like if in console I write, if I write in console 3 plus 4, it is run and then it is gone. If I want to do it again, then again I need to write 3 plus 4, then only it will give 7. But in script, I have written 2 plus 5 once, then I run, and anytime, n number of times also I run means it will show the same result. I run, again it is showing same result, again it is showing result. So n number of times I run, it is going to give me the result. So basically the purpose of script is to save the code. Okay, to make it usable again and again. That is the purpose of script. Otherwise, the code we can make it run in the console itself. No need of script and all. Okay, right. Now, understand this much we understand. Now, let's do one more thing. Let's define the very basic data structure of R, that is called a vector. Okay, let's define a vector. That is C means combine 2, comma 2, 3, comma 4, comma 8, comma 6. And let's run. See, if you run, this will give you as output a one-dimensional array. A one-dimensional array. This one-dimensional array means to say this only has a row. It is not having any column, but only a row of numbers, which is 5 in count. Which is 5 in count. Okay, this is one type of data structure that is called vector. That is called vector. Now, this is okay. Then there is also something called the matrix. Okay, in matrix, you can give such a vector as input. So, okay, first I need to tell that when you open this R software, there are few functions that will automatically load by the basic installation of the software. Okay, these are the backbone of the software. Automatically they will load. Okay, if any function we are using, so are you familiar with the functions that we use in Excel, Microsoft Excel? Are you familiar? Friends, are you familiar with Microsoft Excel? Okay. So in Microsoft Excel, okay, okay. So there is a mixed response. Some are familiar, some are not. Okay, don't worry. If you know Excel, then I just need you to know, just like Excel only, here also there are functions. Okay, like this C is a function. This function takes the input of data and combine it in a vector. Also, you can provide this as a character input, like yes. comma no. Okay, if you run this, but you can't do like this directly. Okay, I will say later why you can't do. It will say error. Okay, it will say error because object is not found. Okay, so that means again we will put this quotes. Now it will run. Okay, okay. So it is again combining the values. So this is vector is a one-dimensional data. Okay, vector is a one-dimensional data. But how what we can do? We can store this data into a variable. Let's define a variable, and name of the variable could be kept anything, but there are only few rules. Like just I keep my name Saurav. Okay, is equals to this vector C. This. Okay. Then whenever I will ask software what is Saurav, it will tell me this is the value of a Saurav. Okay. But assume that I again define it. I defined it again that this is Saurav. Then again I ask what is Saurav. It is asked. It will tell me it is this. So I defined a variable called Saurav. I stored some data into it. Then I stored some new data into it. Then software only remembers the latest data. It does not remember the previous data. So whatever variable I am defining, how it was defined in the last, that only the software will remember. It will not remember whatever has been defined previously. Okay. So whatever it may be, whatever this was defined, it does not matter. What is defined in the end, that is only matter. Okay. So again, if I go to the console and say that Saurav is equals to null is equals to 0. So again it is redefined now. Now it is equals to 0. So now the data is gone, all data is gone. Now it is equals to 0. Okay. So this is how it works. But let us define two different variables. One is, let us call count. Okay. Counting. Okay. And let us call this response. Okay. This is counting. This is response. Counting and response. Okay. And let's do now what? Now see, be careful. Okay. Here the number of elements is same in both. In first also it is 5. In second also it is 5. So only I am able to proceed with the second. Now I am doing data dot frame is I am giving two columns into this counting response and counting. Let's. Do you see the output? Please, Twinkle want to say something.
Hello.
You're audible, dear.
Sir, this one, whatever you are showing, if you can show with some data sets, like any data set in any design, like RBD and all those, for those designs, how we can write commands for those and how we can do analysis with those, then I think so it will be more helpful.
Okay. See, Twinkle, what is the thing? We can directly jump into that, no issues. Okay. But if you directly jump into that, then again I have to come back and tell you that this is the meaning of this thing. This is the meaning of this thing. So basically, I am trying to tell you what is data frame, what is vector, what is the type of data that software understands. Then you will learn the basics. Then you will be able to do any type of analysis, not only design, any analysis. Then we will do few examples by the end of the lecture. Means no, not the end of the lecture. Just we will finish this part quickly. We will finish. Then we will do the examples. So this is just to give you brief. Please.
Okay, sir.
Okay. Yeah. So again, this data frame also I can store. See, if I can store this in df1, so I can store in df1, and this is df1 now. This is df1 became a data which is having two columns. One is response, one is counting. And then there is a function called structure, structure, that can tell me about df1. Then it will tell me, see, df1. Okay. So it is telling me that structure of df1 is such that it is having 5 observations and there are two variables. First variable is response, which is of character type, and second variable is counting, which is of numeric type. Okay. So this is how these are. So we discussed two basic structures. One is called vector, second is called data. So these are basic two structures that are most commonly used. However, it is not limited to these two. There are so many data structures that are supported in our software, but these are only that we use very commonly in our statistical analysis. Okay. So let's now go to the next step, that is index. What is the meaning of indexing? Say if I want from df1, I only want first two rows of the data. What I can do? I will put a square bracket after writing df1. Then I can put a comma in between. So before comma, I can tell what are the rows required, and after comma, I can tell what are the column required. So assume I want first two rows. So I will write C 1, 2, 2 and run. See, only first two rows of the data we got. Then I only want second column of the data. Then run. I got only the second column of the data. Instead, I want first column. Okay. I got first column. So I do not want first two rows. I want first first three rows, four rows. Okay. So first four. But I do not want first four. I want first, third, and fourth. I want. Okay. See, I want all the columns. So remove this, all the columns. Okay, so the square bracket is used for indexing purposes. Okay, this is how you do the indexing in data. Then some of more things will be there when we will do analysis. We will see what is the more things that we can do. Now libraries. Now what is a library? Library is basically a set of functions. Okay, here you can find a full list of libraries that now, because I am regular user, so I have lot many libraries. Okay, but in usually there are few libraries that are built in, that are when you install the software for the first time itself, they will be there, and then you can install them as and when required. Okay, whenever you need to do any specific type of analysis, only then you can install that particular library for your work, and then you can come back and uh, use the basics. Okay, so let's just a minute. I will show you some library. I will show you. So this is a very big list of libraries that been installed in mine. Uh, but let's go to the stats package. Or let's okay. Basic packages they have removed from this. So there are few packages like uh, see, if I want to take mean, okay, I write mean. Mean is a function now. The function mean will take the input as a vector. When I write mean, here comes a letter base. Okay, it means the function mean is stored in package base. Okay, similarly, if I write plot, so if I write plot, plot is a function which will take some values and it is stored in a package called graphics. What is written in front of plot? It is written graphics. So plot function is in the library graphics. So basically what it means, any library that is, it is just nothing but a set of so many functions. Okay. See, this is Agricola. Agricola is a library that is very commonly used in agricultural analysis. Okay, like this is a list here. I can show you. This is a list of functions that is available in the Agricola packages. There are so many functions available in this library. Okay, now what is the use of that function? What is the, that is only required uh, whenever you have this requirement of that function. It is not that if that function is there, definitely you need to use, or whenever you need that type of function, you will load that package and use the function. There are some packages that need not to be loaded, such like base, like stats, like mass, like graphics. These packages are base packages. These no need to download, no need to load. Okay, but there are packages which provide specific functionality, like Agricola is specific for the agricultural research. Okay, so it will give you the specific functions that are required for agricultural data analysis. So what I will do, I will write library and I will write Agricola. Okay, then I will run. So now all the functions that are available in the Agricola library for me to can also unload it. So now, so assume that there is a function called uh, RC. RC. This is function. It only see, there is two things, guys. No issue. My screen is visible. No. Okay. 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 So the R is try uh, the function, the rest of the function automatic. Okay. So if I am writing design RCBD, okay, it will show me the function automatically. Then I can complete the function. But now assume that I have not loaded this package. Okay. How we can unload the package? Just we can go and untick this. Okay. If you untick this, there is a this package is unload. If we tick this, it is the same thing. Tick this package means running the command library agricole. Untick this package means running the command detach package agricola. Okay, both ways. So if I am detaching the agricola package, then this function design RCBD won't be available. Okay, could not find the function. What is telling? Could not find the function. But now if we load the package libraries, okay, and then again we run the function, then it is giving another error, that is it because we have not give the sufficient inputs to the function. Okay, we need to give to the function the number of inputs like treatments, number of application. Okay, so only then. Okay, so if you give this input, so this function is now work. Okay, now we will discuss what it is, what how it is used, and then I will discuss specifically this design function we will use. Okay, so this is how the library thing works. Okay, then what is the plotting? So if you see, we made this data df1. Okay, you remember df1? Df1. Okay, this is something like, so let's try to plot this. Plot df1. Oh, I think we should use a function bar. No? Okay, let it. There is two thing. One is counting. Let's define one more variable. New variable is equals to C3, 6, 9, 15, 6. Okay, there are two variables now, new var and count. Okay, so now what we do, we give it to the plot function and write counting and new var. Okay, code is case sensitive. Okay, always remember this code is case sensitive. If you have used anything as a capital letter, use capital letter. If it is a small letter, use small. So when you do this, you can see here comes a scatter plot in this window. If you can see, you can clearly see there is a scatter plot in this window. It is showing points on the x-axis. It is showing counting, which we have written before, and then it is showing y-axis. On the y-axis, it is showing new one. Okay, good. So this is a basic plotting function in R, but it is a very multi-purpose function. It can be used in so many places. But however, in place of this plot function, we use ggplot function, ggplot2 library, which is actually providing very better quality of graphs. So let's proceed slowly towards the that part. So what are the basic functions? So I want say so there are so many basic functions available like summary. Summary is a very basic function that we can use repeatedly. Summary want to say we want summary of df1. Okay, so it will give you the summary of all the columns of the data df1. Summary means they're telling you what is the minimum of the column, what is the first quartile of the column, what is the median, what is the mean of the column, what is the third quartile, what is the maximum in case of a numeric variable. In case of a non-numeric variable, character variable, it is showing you what is the length of the character. Okay, there is one more type of data that is also very commonly used in our work, that is called factor variable. Okay, just let me define one factor variable and then we will let us define uh, automatic. No, hungry. Let's define a variable hungry is equals to factor. Okay, C, that is factor is a command which will take a vector variable as a input. Okay, so yes, no. So factor is a variable in which repeatedly there are coming only 2 or 3 types or fixed number of responses are coming. Okay, so like this. So now if I check hungry, what is hungry? Okay, oh sorry. See, I did my spelling mistake here. While defining, I did not use R, but while checking, I used R. So when defining, I did not use N. Sorry, N. I missed N. So if I missed N while defining, software will not autocorrect. Software has understood that HUGRAY is the factor, not HUNGRAY. So let's write HUGRAY. Now this is a factor which is having two levels, no and yes. Usually levels are ordered by alphabetically. So that's why no is coming before yes. Okay. So I will tell you later that how it is useful. The factor command is it is very useful command. Okay. Now help function. Now anything you get stuck with R. Okay. Okay, some few basic more functions I will say. There are for getting an average, you can use mean. Okay, so mean of counting, you can get like this mean. You can get standard deviation. Standard deviation basic is SD. Okay, like this. Then you can get what so many functions, basic functions are available. You can use like quartile, quantile. Quantile means to say you can get first quartile, second quartile. Say counting is the basic object. Counting. So which quartile you want? If you want first quartile, give 0.25. You give prox is equal to 0.25. Then it will give you 25th quartile. If you want median, you give zero point 0.5. Then it will give you the median. If you want third quartile, use 0.75. It will give you the third quartile. Okay. So my voice is audible, no? Okay. So like this we can move. So if assume that I want to know how this quantile function works. So what I can do instead, I can just write a question mark here and write a function quantile. Okay. Then I will start this run. Okay. Once you run, the R software will search in all the libraries where is the quantile function. So once it finds, it will show you here that this is a quantile function. This is the uses of the function. These are the inputs. Arguments means what are the inputs you need to give. So first input is the numeric vector that you need to give as input. Second is probs, that is numeric vector of probabilities ranging from 0 to 1. The probabilities ranging from 0 to 1 you need to give as input. Then NARM, names, this and all is okay. Okay. Then here is the formula that is being used by the software. Okay. Different type of formula that can be used. And in the last, there will be example also. Here there is an example written in which the in this this has been defined. Okay. And then it is trying to find the different quantiles of the data. Okay. It is trying to find the 0.001 quantile, 50th quantile, and like this. Okay. So this is how the help function works. Like this, you can get help on the any function. Okay. So again, you can go for the, oh my God, I have low battery. Don't worry. So this is how you are getting the help on the different functions. So let's now dive into the, this is the basic. Let's now get into the main business. So I will not today, I will not take data sets from anywhere else. There are so many available data sets available in the Agricola package itself. So let's use few of such data sets. Okay. So let's explore. Wait. Let's explore air passengers. Okay, this is a time series. Not air passengers then. Hmm. Iris. That is good. Okay. Let's see iris dataset. Okay. First check the structure of the data. What is type of data iris is? Okay. Uh, iris is a data set of 150 observations of 5 variables. First variable is sepal length. Second variable is sepal width. Third is petal length, then petal width. These are four all numeric. And the fifth variable, species. This is the factor variable, which is having three levels. One is setosa, one is versicola, and third is not visible. Let's check the summary. Summary of the iris dataset shows that sepal length has a mean near about 5.84. Sepal width is mean near about 3.0. Petal length is mean 3.75. Petal width is mean near to 1.1, and this is the data of three species. One is setosa, one is versicolor, one is virginica. So this is the data of three different species. So let's say let's find the correlation. No, now when you want to find correlation, usually your software will throw an error like this. It will throw an error. The function for correlation is COR. Okay, correlation function is usually used is COR. So when you give input to the data, so it will say X must be numeric. So X must be numeric means to say all the columns that are provided that you are providing to the function from the data set, they should be of numeric nature. But now what is happening? Your fifth column species is not of numeric nature. That's why it is causing problem. So what I want, I do not want the fifth column. So what I need to do, I need to do indexing. Indexing means I will take only first four columns. So I do the square bracket, put comma. Here I am not writing anything before comma because I need all the rows of the data. Then I write from 1 to 4, I need all the columns. I do not need the fifth column. So let's run now. So first check. It is showing now. Okay. Let's see the structure of this now. Structure of this is showing only four columns. Okay. And 150 observations. Let's see. Now run for the correlation. Okay. Correlation we run now. Okay. This is coming like so up to so many figures. I want it to be okay. Let's define an object M, a variable M, in which we store this correlation M. So if you run M, you will get this correlation. But I want, though, do not want M to be like this. I want to round off the M up to 2 digits. So I write round, give the M as input, and then I give the number of digits is equals to 2. Okay. Number of digits is equals to 2. Then I got this table. Okay. This is now giving you the correlation between sepal length and sepal width. Okay, this is giving you the correlation between sepal length and petal length. And this is the correlation between sepal length and petal width. Okay, but what is the thing? I do not want to see the correlation for all the species. I just want to know what is the correlation for the this versicola species. Okay, I just want to know what is the correlation in case of this versicola species. Okay, like this. So what I will do, I will define a column species. Okay, whenever you define a name, oh my God, species, it should not start with whenever you define a variable, it should not start with a space or numeric, and it cannot contain a space. Okay, let's, and no anything like this bracket and this, nothing. It should not come in the name. Okay, name is a simple Latin. In name you can use capital letters and small letters, or you can use at max what is allowed, you can use dots. Okay, you can use dot and you can use this underscore. Okay, two things are allowed, you can't use anything else. Okay, this and this, nothing you can't use. Okay, you can use dot or you can use this underscore, nothing else. So avoid using any such symbols in between the names. So let me define iris. The fifth column I will define as the species variable. In short, I have written SPCVARI. Okay, so I will filter, I will use this code again. Now what I will do, I want only those rows, I only want only those rows in which this species variable is equals to versicolor. And instead one equal to, we need to use double equal to here. Okay, so let's see the structure of the data now. Now structure of the data says it only has one, instead of 150 observations, it is having only 50 observations. Okay, now you can see it has been filtered. The number of observations starts from 51. So what we can do, we can see here, instead of filtering the columns up to 4, we can keep up to 5. And then again, let's have a look. And instead of running the structure, we will run this and see. The species column only is containing versicolor. Okay, so again let's change it to 4 and find the correlation. Okay, and this is the second matrix M2. Okay, M2. Now M2 is this. Okay, now I run this M matrix. Okay, and let's run this for the second matrix also, that I want to round the second matrix also at up to the 2 digits. Okay, so now let's compare. When we took the whole data, the sepal length was negatively correlated with sepal width. Okay, so let me show you. Let's see, check the help for the iris data. Okay, iris data is actually Anderson's data. Okay, in this what is there, it is the length is being measured. Okay, between the three species, that is iris setosa, iris versicolor and iris virginica. Okay, this is basically a flower. Okay, so now what we are seeing, in case of versicolor, this is the correlation in case of versicolor. In case of versicolor, the sepal width is positively correlated with the sepal length, and petal width is positively correlated, but strength is low. Okay, but when you are seeing the whole data set, then you are seeing the petal length is very highly correlated and sepal width is negatively correlated. But in case of versicolor, you are seeing that it is positively correlated with sepal width and sepal length are positively correlated, and petal length is correlation is less than the total data set. Let's do it. Can we do it for the Setosa also? Let's do for the Setosa once more. Let's copy this code and run for the this. Let's define the third matrix as, and in place we will change the Setosa. Okay, and let's run again. Round and 3 2 digits. Okay, so in Setosa it is, you can see, completely opposite stories. The petal length is showing only correlation of 0.27. Okay, whereas in versicolor it was 0.75, and in the total data set it was 0.87. Whereas in case of Setosa, it is only 0.27. Similarly, you can proceed for the Virginica as well. Okay, Virginica, you see a very high correlation. So this is how you do the indexing. So using the indexing, only we get to know 3 different correlation matrix we got, and we have the comparisons. Okay, so now let's run the let's take some more data set. Okay, some more data set. Let's take data sets. Let's take one more data set. BOD. No.
Hello.
Huh.
Sir, if the data sets you are taking from here, it's already there. But if you want to import some data set,
So there are very many ways you can import. I will tell. I will tell. Okay.
okay, sir.
There are this software supports so many types of data. Okay. Just let me figure out one proper data set that I know. It is not there. It is there in Agricola actually. This CIC is good data, I think. Right. Okay. Okay. Now have a look at this data. This is cotton data. Okay. Uh, so So here you can see this is the site from which it has been taken. Okay, so there are two sites from which it has been taken. In both sides there are different blocks, and they have different lineage from which this has came. And lineage means maybe it is different genotypes that are being taken. Then okay, so let's try to run an ANOVA using this data. Okay, so first we'll run a linear model using so your yield, whatever your numeric variable. So here in case of this, yield is the numeric variable. Okay, so I want site and I want block site, not I want lineage and block. Oh, electricity. Oh, sorry. I need to give data is equals to cotton. Okay. And here we can then go for the AOV as model LM. So model LM is now variable that is being defined. So whenever we write this hashtag in front, that is not the code, that is only a comment. Okay. But when hashtag is not there, rest all is the code. So we defined a variable model LM in which this linear model is being stored, in which we mentioned what is your y is your continuous variable, and these two are the sources of variation like replication and genotype. Okay, this is block is a kind of replication, and this lineage is a kind of your uh, genotype. Okay, so let's run this. Let's run for an ANOVA. Okay, so okay, we need to store this model AOV. Okay, we stored, and then we find the summary of this model AO. See, here you got summary, but can see in case of lineage you are seeing only 1 degree of freedom, whereas in lineage we have four different there, because if you see the structure of the data is telling you that lineage is integer, but we want lineage to be a factor. Only then it will recognize. You put lineage as a, you use lineage as a factor, then and this. Now you can see this is having 3 degrees of freedom. Earlier it was showing only 1 degrees of freedom because it was counting it as a numeric variable. Okay, and it was coming only 0.02 as significance, but here it is not significant. Here it is properly we took it as a, it is been taken as a factor, and we can see it is not significant. Okay, so now you got what is the difference between why it is important to tell the software that this is a factor variable. Whenever you are using a replication variable, block variable, that time you need to again see. Somebody yesterday asked how to arrange the data. See, here you can see an arrangement of the data. Your numeric variable will come in the one column. Okay, your whatever else is there will take, treatment will come in one column, replication will come in one column. Okay, this is kind of the arrangement you need to do for your data. Okay, but something is still, you know, there is a factorial experiment in which you can study the interaction as well. But for that, there should be sufficient number of replications. I don't know if it is there or not there. Let's check. If you write the star in this place, it will run. Okay, just let's check. Okay. And, and, um, okay. So here what we got, what extra we got? We got an interaction effect. Interaction of this genotype, lineage, and block. We got an interaction as well. What we changed in the formula, instead of plus, we put star. Star means multiply. Okay. So he like this, you can run a factorial ANOVA. If you use plus, that is the RBD. Okay. But if you now use star, then it is showing you the factorial ANOVA. Okay. But see, block automatically it is taking as factor only. Okay. No need to convert. But lineage it was not taking as factor, so need to convert. Right. Now, okay. That query was there, that how to import the data. Okay. So there are few ways. First, there is one command that is called set WD. Setting a working directory. Firstly, you should know what is get WD. Get WD is you know your working directory. Okay. So this is my working directory now. So I can change my working directory. Right. Okay. So if I want to change my where my data is there now. Wait once a minute. Let me share my whole screen. Mm, you can see my screen now. So assume my data is there in this library. Okay, in this place, in this folder, I have data. My data name is this. Okay. Okay, this is all in CSV file. This is my data. Let's open this data file. It is little slow. Okay. So say assume this is my data file, whatever it might be. Okay. So it is having three sheets, sheet 1, sheet 2, sheet 3. So I want sheet 1 to be imported. So one way is I can set this folder as my working directory. I copy this address from here. Okay. I copy this address from here. This is the address. Then I set this folder as working directory, like using the command set wd. Then I will put double inverted comma, and I paste. And in place of this, I will put 2 times slash. Okay, 2 times slash I will put and run. Okay, then I can use read. There is library read Excel. Okay, I will load the library, and then I can run the command. I first give the name to the data, my desired name. Okay, any name you can give, but I tell you the rules. Okay, already I told you the rule. Then I write read Excel, read Excel, and here I write the name of the Excel file. What was the name of my Excel file? Okay, this is the name of my Excel file. I copy the name of the Excel file. Again, I go to the this. I could write double inverted commas dot Excel exec. Okay, then I can also mention that the sheet name is sheet 1. By default, it will take first sheet. Okay, if you don't mention the sheet name, it will take the first sheet. So let's see. So this is now your data has been imported by the name my desired name data. Okay, let's check the structure. Okay, so this is now it is showing. Okay, first character variable, numeric variable, numeric variable, numeric variable. So one more way is there. Here in environment, there is this is one way. Okay, to import your data. Can set the working directory, then read Excel, then write the name, and well, there is another way. This is you click here, import button is there, import. When you click in environment, in this window, okay, environment, there is an import button. Click import. Okay, click import, click from Excel or whatsoever data. Okay, see here so many options are there. You can click from text, from SPSS, from SAS, from Stata, from Excel. So I am importing from Excel. So here you can click browse. Okay, you click browse. If you click browse, it will open your working directory. Okay, whatever it may be. So let me click this file open. Okay, I will click this file and I'll click open. Then it will retrieve the data from the file. Okay, it will show you a display of the data. Okay, this display might not be the complete data. Okay, it might show you the complete data, it might not show the complete data, depends how big the data is. Okay, don't touch these options here. Don't just you can change the name. Here you want to change the name, you can change to any name, but remember rules. Do not start from the numeric, do not start from the space, and do not give space in between the name. Okay, do not use the special characters other than dot and underscore. Okay, let's put any dot name. Okay, so now import, click import. Then oh, it has not changed, it did not change to the any name. Okay, no problem. It has came as FRBD analysis. Thus, it has came by the name of sheet. Okay, it did not change, but usually it will change. I don't know why it did not work, but it will work only. Okay, this is one way to paste. Now, one way to bring data to this file. Okay, and I think I am running out of battery, and problem is that power is not there. So let's finish this presentation as soon as possible. Let me load up. Right. Okay. So here you can see now, this is the way you can import data. Okay. Then one more thing I wanted to tell, there is a see now here you can run the LSD also. Okay. LSD test over the model AOV. Okay. I want to know about the block. Okay. Just save it in the testing. Okay. So here it is coming now, testing. You can run testing. Okay. So here you got the test results. This is your, this is your CV, this is your CD, and this is all other data you need. One more thing that I wanted to tell is, I think we are short of time, but I will try to show some example. One is library ggplot 2. Okay, so let's put it. Okay, library ggplot2. So in ggplot2 there is very diverse plots you can make. Okay, say data is equals to let's use this data itself. Okay, let's use the cotton data itself. Data is equals to cotton plus, okay, here one more thing we give as output is aesthetics, what you want on your x-axis and what you want on your y-axis. So assume that I want on x-axis, I want where is the cotton data here? Okay, on x-axis I want site, and no, site we will take later. On x-axis I want lineage, but lineage also I want as factor. X is equals to factor lineage, and y is equals to I want yield. Okay, so let's make a bar plot. Okay, geom bar. Okay, then I want to run. Yield is not there. Yield, what is the name of yield? Misspelling. Spelling is wrong. Okay. What is the problem? Okay, let's put a box plot. Okay, so you can see there is a box plot showing us the box plot of first type of lineage, second type of lineage, third type of lineage, and fourth type of lineage. Now I can split into the sides. Okay, the facet grid can make a grid based on the site, and also there are lot of options in the themes. I can use a theme classic. Also I can use something to put color as well. Okay, let's use what let's use epoca. I don't know what is this epoca variable telling us, but let's use this variable to color it. Okay, use AES. So fill is equals to epoca. Okay, that's the huh? Not doing. This is not working. So let's put as lineage. For lineage. So you can see now our plot. Okay, you can further modify it. Okay, it's nothing like that. There's so many modification options are available. Okay, so like this, I plotted now on this side there is a lemma site, and then you can see clearly that this site is showing higher levels of yield, whereas the lemma side is have showing quite lower levels of yield. Even this fourth type of lineage is performing quite good in this piso, and this fourth type of lineage is performing poorly in this lemma site. Okay, whereas almost all these are performing less only in lemma site. There might be some issue. And then also you can see there is a anomaly. Here you can see there is an outlier that some value is showing very high yield in lemma also. In case of second lineage and also in case of third lineage, there is some outlier in this case. Okay. Then furtherly, if you want to improve this graph, you can use like XLab. XLab I want to give as a lineage. Okay. Then YLab I want to give as uh, assume that I want to give yield in kg per hectare. Okay. Then I want to use um, axis text and text family self. I want to use Times New Roman. Okay. Then also, oh, this is sans. I want to use sans. Not changing. Oh my God. Sorry, guys. This got my laptop got off. But so this is most of more or less from this basics of. Hello. So I'm sorry that I cannot hear. Actually, there is a power issue is there, so I cannot connect to power. But if you miss till now, I have shown this much is there. So you want to ask anything, means you can ask.
Hello.
Ah, yes.
So, sir, in R, basically, the writing these codes we need to learn.
Writing this code only is the last thing that you need to learn.
Uh,
Me,
but,
huh.
but sir, like for particular, like okay, I want to do this analysis, but I don't know how to write the code for this. From where we will get that?
Simply you search. There is not a big deal. I told no yesterday also I told, and there are so many websites that are providing the code for common type of analysis, whatever analysis commonly used, no, again and again. That kind of code is already available on the so many websites are there. Once one I provided yesterday, our companion, and see. You just need to learn the basic terminology. Okay. Once you learn the basic terminology, what is function, what are the arguments, what is data frame, what is a vector, what is a... So if you learn all these things, it will be easier for you to search the things so that you can get your work done. Because if you are getting some error, you are unable to read that what is the error. You are unable to know what is there. You do not get that what to search. But if you understand the basics, then you'll understand what you need to search. That is very different. What is the... if you do not know, you copy the code and you run it and you're not getting the result, then you do not know what you need to search. Okay. But if you get to understand, if you get to know what you need to search properly, then you will get the right answer and you'll modify your code and your code will work. That is the thing. You, this and all we cannot see. Even I will tell you about myself. So nobody taught me this R. Okay. I have not taken any formal education to learn the software R. Okay. I had I had to learn it because there was, during, I will say this is now 6 7 years back, I need to learn one analysis that was possible to be done in this R software. So I copied the code. I did not even know what this code is doing. So I tried to run something. Sometimes it will show error. Sometimes it will show something is happening. Then I downloaded some book. In that book, that was something else was written. Then I tried that also. Then like this, sometimes it will come error. Sometimes it will not show error. Slowly I learned when it is showing error. What is the meaning of that error? What is the... slowly only you develop the vocabulary. Okay. Like in English also, you read more books, then you will get better in vocabulary. But if you read only the syllabus book, then only you get to understand only the basic English and basic talking skills. But if you will keep reading more, if you read some English newspaper, you watch some English movies, then your vocabulary will improve, your hold on the language will improve. It is same thing that happens here. So you are working with this language, working with this software again and again. You are coming across with different things on different times. Then slowly you will learn. Okay, when this thing is happening, that means this is the solution. If this thing is happening, this is the solution. If this particular error is showing, that means this might be the mistake. If this error is showing, this might be the mistake. So slowly you will learn. This is not that, see, even if I will give you this code, this is the code for ANOVA, you now do. It is not directly possible to be done. Okay. For that also, you need to make some modifications. Not, not huge. You need not to write it from zero, but small, little, like maybe the name of your data is different, name of the columns in your data is different, then you will change. No, if you are, if I am using yield, you might not be using yield, you might maybe using chlorophyll content, you might be using uh, plant height, you might be using uh, something else, maybe anything, starch, you might be finding, you, your column, my column name is genotype with small g, your column name is genotype with capital G, then also it will show error. Because until and unless you change the capital small g into the capital G, because your sheet, it is capital G, so you have to change it to the capital G. If in my sheet it was treatment, in your sheet it is genotype. So you need to remove treatment and write genotype. That is what you need to learn. That what is I need to correct in the code for that, for how to make it work for you. That is what you need to learn.
Okay, sir. Thank you so much. It was helpful.
No, miss, I am really, and moreover, if you face any issue with any kind of code and all, so miss, I am here only, no problem. But the basic thing I want to tell you is it is just the practice, nothing else. When you practice more, you will get keep on improving. You will keep on getting better. So you are a master student.
No, sir. PhD.
You are UG student.
No, no, no. PhD student.
You are PhD student. Okay, okay, okay. So may I know which discipline?
Genetics and plant breeding.
Okay, very good, very good. Genetics and plant breeding means you should have very good understanding of
Yes.
statistics. Uh-huh. Okay, okay, very nice. Then, but I tell you, I know so many of my friends in plant breeding who use it quite nicely. This R software, and I know from plant physiology few people, from agronomy few people, they know, means they do not know exactly what the software, what is the command, what is this, but they have learned that if they get some code, then they can manage to do it for their work. They do not know to write the code, but they now understand that if this is the code, how to do for their data. That's what they understand. Okay, so don't worry, it's nothing very difficult, it is easy only, you can learn, I assure you. And there is learnr. Learnr is package, okay, you search it, learnr, learnr. I will share the link in the group. Okay, so first you install that package learnr. That package also has helped me a lot. So using that package, you can start learning, and then you can um, miss. It will help you surely. So it will give you a question and ask you what will be the answer in code. Okay. So if you write the correct code, then it will go to the next step. Otherwise, it will keep on showing the error. So if you want some hint also, it will give you hint. Then you can write the right code and proceed. So that like that you can learn. That is also good way to learn. Okay. That package has helped me in many manners. Okay.
Okay, sir. Thank you so much.
Hmm. Then anyone else?
Okay, thank you, Dr. Singla, for taking this wonderful session, and our participant for attending the class. So now we are closing today's session. If you have any doubt, you just put it to our WhatsApp group, and Dr. Singla will definitely get back to you. Okay, thank you all.
Thank you.